Safety is probably one of the most crucial and important factors that is overlooked by the customers when buying a new car. Obsessing over features has become the new cool. And I believe that safety should be given the utmost priority. Thus, to talk about safety and highlights its importance, this time we have with us Florian Wagner. He is a safety engineer and is currently working as a consultant at the MSG Plaut in Vienna, Austria, and advises customers for the automotive industry on functional safety and models based systems engineering. So, we have tried to break down his journey with cars and engineering on this episode of Shift with Motordrift. Welcome, Florian. Glad to have you on the podcast.
Thank you for having me.
Yeah,
Glad to be here.
yeah. So, Florian, I had a question like, were you into cars when you were younger? And if you were, like, how did you get interested in them?
Um, Probably I was. I read car magazines,
Mm,
but then somehow my interest in cars a little bit leveled out.
mm,
And for some years, I worked also in the railway industry, and then came the opportunity back to work in the automotive industry. So to be honest, I'm not the most car person probably, but I think it's a very interesting field to work in.
yeah, for sure it is. And like, how did you get interested in the field of engineering?
So I don't really know. When I was 10 years old, or now 14 years old, then in Austria we had to decide on in which school we want to go further.
Mm,
And I was I was interested to go in a technical school.
mm,
I don't know exactly why. Probably I always played with Lego and so on, so I was
mm,
somehow interested in constructing and building things.
mm,
But I cannot tell you exactly.
mm.
It was somehow the right choice for me.
Yeah. So, like, you were always into like science, stuff like that, science, engineering, things like these, maybe.
Yes, for sure. That's a little bit my people around me. Also were interested in science,
Mm,
somehow in technology and engineering, and then I also followed somehow their paths probably.
yeah.
But for me, it's also still the right decision to go in this direction.
Mm. And how was your experience working as a system engineers on the railway projects? How was the journey experience?
Yes, so if you look in the railway industry globally and then look, for example, how big the car industry in Germany alone, for
Mm,
example, the railway industry is a very small industry.
mm,
And when I was working there, it was not a very changing field. It was somehow we could say a very conservative field,
mm,
relying on very established techniques,
mm,
and also from the systems engineering side and from the safety side. But then there started a little bit of change because uh, in Europe it was the European train control system was introduced,
mm,
and there was the need to a little bit more collaborate with other systems with because we then until then the systems were all national systems, and if you
mm,
look on the map of Europe, you see that are very small countries, and all these countries had their own systems. And now there was the need to cooperate to establish the same technology in every country. It's still ongoing, and I think there was also the need to to make a new to introduce a new way how to engineer systems. And there I will that's the where made the first contact with model-based safety, no, model-based systems engineering in the first place. SysML uh, it was the language we used there, and I still use SysML basically for model-based systems engineering. And there was a little bit a change. It began to modernize. The industry began to modernize itself. Yeah, and then I somehow had the opportunity to focus more on the safety parts. I first heard of safety engineering in school, and then you learn it, and then you say, okay, I don't need it now, but what I learned through my career is that maybe you learn something years in the past, and then you need it some years later, and then it's good that you heard something about it, and then you can use it. And I had the opportunity to go in this field, and I think it's very interesting. I think that's not the most popular opinion, but I think it's very interesting. But it's also very important because I always, to go back to your first question, why I pursued a career in engineering, I always wanted to build something where and then go through the streets, through the city, and say, okay, I worked on this system. And with safety, there is also this aspect to say, I worked on this, and it's something valuable I provided to the system. So to make something safe is probably the most important thing in engineering, I would say, or one of the most important things for sure, to prevent harm from people and stuff.
Yeah. So basically, safety engineering is designing systems that like improve the safety of a vehicle.
Yes. So probably some years ago, not too much years ago, they engineered the car, for example, and then said, I think we should also look on it. Maybe it's not safe enough, and then try to improve it, make some additional systems. And now the approach is a little bit shifting in, okay, how can we make the system safe from the beginning? So what is standard now is that you make an analysis at the beginning and look on it, what has the potential to be dangerous. So for example, if we look at the car, if the car crashes, the passengers in the car are in danger, and people in the surroundings of the car are also at danger, and you have to prevent this. That's the hazard, it is called. And then you have to look on how can this hazard happen, and the analysis proceeds, and therefore you need to assess the hazard. How big is the damage, or how big is the harm? So if you just say, okay, there is just a possibility that someone has a little scratch, then you don't put that much effort in preventing it. And the second aspect always is how in what frequency can this hazard occur, or how probable it is that something dangerous happens. So if this happens every hour once, that's too often. If you say that happens just statistically once in 10 years, that's probably not that often. But you also have to keep in mind what is the effect of the hazard. So if it's just a scratch you can get, and it happens just once in 10 years, you don't have to put that much effort in preventing it. The other extreme would be if something could happen every hour and 10 people could die, then you have to put the most effort in it to prevent it. So this is the risk analysis. Risk is always the outcome and the probability. That's one of the key tasks you have to do in safety engineering, to look on it, what can happen, how often it can happen, and then you have to think how to prevent it. Everything following is based on this.
Mm. Like for example, every system like ABS and all of these systems that have like evolved over the years, these all have been designed and made by considering these scenarios.
Yes. So that's a very good point. You also have to keep in mind what is the scenario of when you are thinking of hazards, because something, for example, if you say you have a resistor, an electric resistor, and it burns, maybe the effect is that the car stops. If that's the case, that's you don't want that the car stops, but from a safety perspective, it's okay. So a stopped car cannot drive someone over. But if you, for example, if a resistor burns and then the car accelerates uncontrolled in an uncontrolled way, that would be something very, very bad. And so context is also something what is really important, and therefore all the scenarios, what can happen in a certain scenario. But you're starting from a very high level perspective. You have to start somewhere. So if you say you're making a car, it's clear that the car can accelerate, the car can be fast, because otherwise you don't want to build a car. Because one approach can, so on a very naive way, we could say, okay, the car should never accelerate and it's safe, but that's nonsense. We want to build the car to move people. Okay, so you start on a certain point. You say, okay, you have a car, you know what a car is and what a car does. You have all these basic functionalities, and all this stuff, what we say is an inheritant property of a car. And then you can make your first analysis. And then you look further, okay, how does your special car look in particular? Or maybe you can, if you have two options, shall I build it this way or this way? Then safety may come in and say, okay, it's better to keep to follow option one, for example, because then it's easier to make it safe. So that would be a modern approach to follow a safety, to implement safety from the beginning in the system.
Yeah. And like for as long as like you can remember, how has safety in cars like evolved, particularly from the time you started studying to now? Like if for example, if you take the like 10 years back, what was the safety level in cars and what is the safety level in cars now?
So from what I remember, it did not change that much, I would say, but maybe I can a little bit expand the answer. If you look back, safety was always something what the engineers had considered when building a system. But for example, in Europe, in the 90s, they started to follow an approach called functional safety. So there are safety functions. They need to be implemented with a certain level of rigor to assure that a system is safe. And based on this idea, which is originated in an explosion of a chemical plant in Italy, they then developed this idea. Based on this basic idea, this idea expanded to the automotive industry, to the machinery industry, and railway industry, medicine, and so on. So to look on the system, what are the key functions, what are the safety functions to make the system safe? So and we're now, when we're now looking at the current situation, we have very highly automated cars, and also we are trying to make cars self-driving or autonomous, how do you want to call it? And now this approach is still important, but it's not sufficient anymore, because just because something is working in the way it was designed, it does not mean that it's safe in every context. That's what I said at the beginning. You have to keep in mind the context. So what does that mean? Or what are the challenges now? We have now, if we are thinking of autonomous cars, we then will use probably cameras, lidars, radar systems, and process this information, probably with deep learning and machine learning algorithms. And it's then very hard to say now if something is really safe in every context, because the context changes. So if we had, for example, the electronic stability program, the ESP in the car, it only looks on certain sensor information and a very limited information, and the information is processed based on a very strictly defined model. So basically curves. When it say, okay, if we are, if the acceleration of the car is too high, then we need to break this car down so that it's stable on the street and nothing bad happens. Now we have a lot of information from 3 different sensors, high definition sensors. That means we have a lot of information, and we are trying to process this information, but it's not that easy to define what shall happen when a certain input comes. So this, all the instruments functional safety gives us to regarding how to code a system, how to verify a system, and so on. They are still good in this place, but not sufficient, because we need to think more of, okay, what is really a safe behavior in a certain situation? And the situation is not that clearly defined. So this is somehow the challenge. And what is now a bit new is we have the new standard, the SOTIF, the safety of the intended functionality, which focuses more on the functionality of the system, and not that a certain defect of the system can cause something dangerous, but we are looking on how can we keep the functionality of the system safe. So that's almost the same, but it's not the same. So, and therefore there is now this change. And yeah, the other thing is, which is true for the car industry, for the automotive industry especially, the functional safety algorithms relied on that there is a driver in the car. He or she can take actions to prevent dangerous situations. Now we are pushing away the driver. We are keeping him or her out of the loop of this control loop, basically, and putting more tasks to the machines. Now we don't have this fallback level to say, okay, there's a driver. If something happens, there's still a driver. And in the automotive industry, probably the rigor was not, it was needed to be that high, and now it must be that high, because more automation means that we need to build more dependable systems. And this is now the change from some years back, and what is the future, probably.
Yeah.
I hope this answers your question somehow.
Yeah, it does. And like what I have heard from engineers is that whenever, like for example, they start building a new car, they build it around the driver. They build it around the safety of the driver and the passenger. That's the main goal. Like at the final product, from the starting to the final product, the goal is to, like build the car safe around the driver and the passengers.
Yes, so it's still must be safe for the passengers. And the driver becomes just a passenger. And as I said, it was always the goal to provide the driver all the information to make certain actions. So if, for example, I don't know, you're driving with the radar and the radar keeps distance. So it's adaptive cruise control, for example. Yeah. And if the radar fails, then you get an information, okay, now you're in full charge. And the driver knows that because he or she got the information. But now looking on autonomous cars, if they have a radar and the radar fails, how should the machine react? Because the machine lost its eyes, probably, if it's metaphorically spoken. Yeah, so there is a change. And as you said, we had at the beginning, or currently still, we have the driver, we have the passengers, and we can build everything around them. And now the driver is not the driver anymore, but one passenger more. And we need new approaches. But it helps that we are not shifting from not self-driving to fully self-driving. It helps that we have a certain change step by step, and therefore can implement ideas, also step by step.
Yeah. And like, I think that there should be something as a default. For example, if the self-driving system in a Tesla fails, then like, there should be a default mode such that the car goes to like stop at the side of the road, and maybe like send something like an emergency alarm to the nearest service center, something like that. Because I have seen the incidents where like the driver was asleep and the car was moving, and then the police had to stop them.
But this is also there is also important to keep in mind context, because I don't know how fast you can drive on motorways on so-called Autobahn in Austria and Germany, how fast you can drive in India, but we can drive up to 130 kilometers per hour. So this is it would be a problem to stop from there to zero immediately. You have to brake gradually, step by step. Yes, gradually. The other way around, probably in a city, it would be the most safest to stop immediately. Even if a car crashes behind you, it's just a crash with, I don't know, maximum 50 kilometers per hour. So it depends also on context, but it's absolutely true what you said. But also there is this challenge to keep in mind the context.
Yeah, all right. And like, what were the things you learned when you went for that master's degree in safety and system engineering? If you can elaborate upon that.
What the things I learned. So I came with a little bit of experience from the company I was working there. But what I learned were so when you're learning safety in a company, you're learning it on the job. So probably the first thing I learned was the basics. So I explained before that risk is always the combination of harm and probability of occurrence. That's something you probably knew from your feeling or from your experience, but that's something you then learn really from the theory. So that's a basic example, and this is also evolving. How is the wording the right one, and so on. So I got a more a fully picture of what safety is and what safety engineering is.